We're going to start with the subtraction rules again on page 17 of section R1. It was on the last part of the previous recording, but we're going to start all over again. In order to use subtraction, what we do when you subtract b from a is actually take the opposite of what's being subtracted, which is b, and then add that to a. So a minus b could be written as a plus a negative b. If you look at it, you can actually see that you just put a plus sign in front of the negative. So it makes that be a negative number, and then you're adding instead of having subtraction. The examples that we have here are 5 minus 7 is the same as 5 plus a negative 7. The advantage of this is that we have the rule that was in the previous section where we have one positive and one negative, so we take the difference, so 7 minus 5 is 2. The absolute value of the negative 7 is larger and its sign is a negative, so then the addition becomes negative 2. The other way that you could look at it is if you have 5 things and you lost 7, you would be in the hole 2. Or if you were looking at it in terms of your checkbook, if you had $5 in your checkbook and you wrote a check for 7, then you would have 2 left. So on the left side, looking at it as 5 minus 7, it's subtraction. On the right side, it turns it into addition. If you are good with the subtraction and that doesn't bother you, can certainly leave it as subtraction. If the subtraction bothers you, then I would go ahead and change it to addition. Addition is a little bit easier sometimes than subtraction. Problem number 2, 10 minus 5 becomes 10 plus negative, 10 minus 15 becomes 10 plus negative 15, which gives you a negative 5. 9 minus 7, none of us would go ahead and change that. We would just go ahead and take that as a 2. If you wanted to rewrite it, it would be 9 plus a negative 7 is equal to 2. Negative 3 minus a minus 4. This one is very important because it's got that double negative that we mentioned in the last recording. The double negative becomes a positive, so anytime you see that minus minus 4, you can go ahead and change that into a plus 4, and now we have minus 3 plus 4 gives us a 1. Number 5, minus 12 minus a minus 3. Again, we have that double negative. The double negative is going to be a positive, so we replace it and write a plus 3 instead of a minus minus 3. Then we have minus 12 plus 3 gives us a negative 9. At the bottom, it talks about how to turn it into subtraction again. The first number is what's in your checkbook. The second number is the amount that you're writing the check for. The multiplication and division rules are on page 18. We're going to talk about these rules. I'm not going to spend a whole lot of time on them. If you haven't had them before, or it's been a long time since you've had them, I would suggest that maybe you make an index card so you can go back and retrieve these rules if you need them. The first one is when you multiply or divide two numbers with different signs, that means one is positive and one is negative, the answer is a negative number. Rule 1.5, when you multiply or divide two numbers with the same sign, so that means that they're both negative or they're both positive, the answer is a positive number. So the rules for multiplication summarized are, if the signs are the same, so it's a positive times a positive, our answer is a positive, or if it's a negative times a negative, our answer is positive. The two examples are over on the right hand side. 5 times 2 is 10, negative 5 times negative 2 is a positive 10. So you might want to have, like I said, an index card handy on this one, because when you multiply two negatives, you get a positive. When you add two negatives, then you still have a negative. So that's the one rule that is sometimes easily confused. If the signs are different, one's positive and one's negative, your answer is a negative. And the two examples of this on the right hand side, positive 3 times negative 5 is negative 15, and negative 3 times a positive 5 also gives us a negative 15. The rules for division on page 19 are similar. A positive divided by a positive gives us a positive, and likewise a negative divided by a negative gives us a positive. 10 divided by 2 is 5. Negative 10 divided by negative 2 also gives us a 5. If the signs are different, negative on top, positive on the bottom, or vice versa, positive on top, negative on the bottom, we still get a negative answer. On the right, negative 10 divided by 2 is equal to negative 5, and 10 divided by negative 2 is also equal to a negative 5. One special rule that we want to talk about on page 20 is division by 0. Division by 0 is impossible. That means that you cannot have a 0 on the bottom or in the denominator of a fraction. You can have one, if there's only one and it's on the top, it can be on the top of a fraction, but it cannot be on the bottom. 10 divided by 2 is equal to 5, and we can check that because we can take the number on the right, the 5, and multiply it by the number on the bottom, 2, and get the number on the top. That's our way of checking it. So if 10 divided by 0 was possible and equal that question mark, then it means that we could take 0 times a question mark and get a 10. Well, there's no number that you can fill in for that question mark in order to get a 10. So all we can do is when you divide by 0 is just say it's impossible to do, or it's not defined. If you try it on your calculator and take 10 divided by 0, it's going to flash up an error message at you. On page 21 and 22 of your handouts are a number of problems that deal with signed numbers, which means positive and negative numbers. The answers to all of these are on page 23. Also in this week's lecture section is a file titled Additional Work with Signed Numbers. There are a lot more of the problems of the same type. These are for your benefit to try to work. The answers are with those also. They're not anything that's assigned to you, but if you're able to do these problems that are on this sheet on 21 and 22, and then that additional sheet with ease, then the rest of the class, I guarantee, will go very, very smoothly for you. If you're still having troubles with some of these, like example number 15, minus 6 minus 1, if that bothers you, then try to find some way around it so that it makes sense to you and that you understand and that you can work with it. If you're not successful, give me a call or email me and I'll help and try to see what I can do to help you. One like number 15 is one that very frequently gives problems. So try these problems and make sure that you can work them. I would try these problems before I went ahead and went on. On page 24, we see a section that's titled on the far left, Living Things. Living things are broken down into two categories, things with brains and things without brains. Things with brains are broken down into two categories of non-humans and humans. Non-humans are broken down to cats and non-humans that aren't cats, and cats are broken down into female cats and male cats. The purpose of this chart is to show you that if you had an instance of a female cat, let's say the cat's name was Frisky, then Frisky would be a female cat, she would be a cat, she would be a non-human, she would be a thing with a brain, and she would be a living thing. In other words, it's like a family tree that she would belong to everything that was in a category higher than she was. The purpose of doing this is so that we can take a look at our system of what's called real numbers on the next page. The real numbers are all of the numbers that we know about. The rational numbers are those that either terminate or repeat, which we'll look at on the next page. Irrational numbers are non-repeating decimals. The most famous one is pi. The most important thing I would like to look at here is the box of category called integers. It is the negative whole numbers, 0, and the positive whole numbers. So you see that box in the middle there? So negative 1, negative 2, negative 3, 0, 1, 2, 3, and so on. We'll be talking extensively about those. One of your homework assignments on your practice test asks you to name all the integers between two particular numbers. So what you would want to do is plot those two numbers on a number line and then list all of the whole numbers, both positive, negative, and 0, that are between those 2 points. The other things that you see out to the right are the whole numbers and the negative integers, which are below the integers, and the whole numbers are broken down into natural numbers and positive integers. We'll take up on the next page in the next video recording.